Hello, everyone. My name is Marcy Samuelson, and I am Marketing Manager for the Developer Initiative here at Oracle. Thank you for attending today's Tech Classroom Managing Kubernetes Applications on Oracle Cloud with Nirmata. If you have any questions during the workshop, please put your question in the Q&A area, and we will answer your questions as quickly as possible. This webcast is being recorded, and we will make it available shortly after the webcast concludes. Again, thank you for joining the Tech Classroom Managing Kubernetes Applications on Oracle Cloud with Nirmata. This webcast will be presented by Ritesh Patel, VP of Product at Nirmata, and Gilson Malo, Principal Product Manager at Oracle. At this point, I will turn it over to Gilson.
Thanks, Marcy. Happy to be here today with Ritesh, Nirmata founder, to share what Oracle and Nirmata have been doing together in the past few months. This is the Oracle Safe Harbor, and I'll give you a few seconds to read it. And if you're watching the recording, feel free to pause it if needed. Before we jump into Nirmata's content and demo, as usual, let me give you an overview of Oracle Container Engine for Kubernetes, also known as OKE. So why Oracle Kubernetes? OKE is a fully managed, scalable, and highly available service that you can use to deploy your containerized applications to the cloud. Oracle Kubernetes is based on the upstream version supported by the Cloud Native Computing Foundation, CNCF, so no vendor lock-in. And that also means that everything you have tested with Kubernetes on premises can be ported to OKE without the need to re-architect it. So use OKE when your development team wants to reliably build, deploy, and manage cloud-native applications. Oracle's cloud-native services leverage highly performant next-generation Oracle Cloud Infrastructure, also known as OCI. These services can be categorized into application development plus operations, and observability plus messaging. As you can see here, we provide several cloud-native services that, combined with OKE, will give you a robust and scalable cloud-native service environment. For example, we have a streaming service, which is fully Kafka compatible, logging, compatible with Fluentd, native monitoring, notifications, events, API gateway, infrastructure as a code that allows you to run your own Terraform stack in the cloud through the Resource Manager UI, functions or serverless, and several other services that will assist you with your most demanding workloads. And since OCI and OKE are based on the open standard services, you're more than welcome to bring your own open source software that you're familiar with to use along with Oracle Cloud Native Services. Oracle is a Platinum member of the Cloud Native Computing Foundation and a member of the Open Container Initiative Linux Foundation project. So we're very serious about using open standard services and supporting the Linux community in general. Oracle is the only major cloud provider to deliver and support a unified cloud native solution across managed cloud services and on-premises software, supporting seamless bidirectional portability of cloud-native applications built anywhere on the framework. As I mentioned a few seconds ago, Oracle Cloud Native Framework is based on open and conformant CNCF standards. So that means, again, no vendor lock-in. And applications built on that framework are portable to any Kubernetes conformant environment or any cloud or infrastructure. For example, applications running on WebLogic on premises can be easily containerized or put into containers, and then lifted and shifted into Oracle Container Engine for Kubernetes without re-architecting and rewriting any code. This makes the migration to public cloud very easy. Terraform configurations can be reused across Oracle Cloud environments, so they can be modified to be used in other cloud environments and be automated with Oracle Cloud Resource Manager UI for Terraform stacks, and so much more. This slide contains just some few examples of what Oracle has been doing in regards to open standard services and in regards to how we're supporting the Linux community in general. Oracle's second generation cloud infrastructure, known as OCI, provides bare metal, virtual machines, containerized compute, GPUs for performance-intensive workloads such as AI and machine learning, and a variety of cloud storage options like block storage, object, file storage, and archive. OCI offers a fantastic array of services for developers to build modern applications, and OKE uses OCI as the main platform for its services. Regarding to the framework and programming language options, we don't restrict our users to specific programming language option. So you have the choice to use any programming language and framework like Java, JavaScript, Python, Ruby, and you can use any DevOps tool as well. So no restrictions in regards to programming language options. In addition to that, we provide a set of free tools like Visual Builder Platform for your DevOps framework, but you can also use the ones you're already familiar with, as shown on the slide. This is the enterprise cloud you have heard of that provides an integrated data platform for the most demanding users. This includes our flagship autonomous database, but we also offer the choice of other databases like MySQL and Microsoft SQL Server. Finally, we provide several services to help you manage, secure, and monitor your applications. And today, you will see how you can use Nirmata to manage OKE, along with other Kubernetes platforms that you might be using. So more details in a few minutes. Okay, let's talk a little bit more about Oracle Container Engine for Kubernetes, OKE, and Oracle Cloud Infrastructure Registry, OCR. OKE is a developer-friendly and enterprise-ready managed service that runs highly available Kubernetes cluster with the control, security, and performance of Oracle Cloud Infrastructure, while keeping pace and compatibility with the CNCF ecosystem. For example, OKE supports Kubernetes Helm for easy deployment of Kubernetes apps, and several other features like bare metal support for worker nodes, along with virtual machine, HPC shapes, and more. OCR, or Oracle Cloud Infrastructure Registry, is a highly available container registry service that enables users to easily store and share their container images. OCR allows users to push and pull images with the Docker CLI, for example, or pull images directly into their Oracle Container Engine for Kubernetes deployments. OCR is a Docker v2 compliant and can work with OKE or other container engines as well. So interoperability is assured with both OKE and OCR products. To recap, we have covered some of Oracle open source initiatives and DevOps solutions, along with a quick overview of OKE and OCR. Now, let's talk about pricing options. The gray shaded area on the left designates the functions of the Oracle, what Oracle manages for our users, including an integrated registry, image storage, and a fully managed container engine for Kubernetes. Oracle will manage the etcd and master nodes of the Kubernetes instances in a high availability setup for the users. Upgrades to new versions of Kubernetes will also be supported in the container engine dashboard within the OCI console. So it's very easy to upgrade your OKE master nodes along with your node pool servers, and you decide when to do it to mitigate downtime situations. Users will manage the cluster or the worker nodes that are set up by the managed service for that instance, their own OCI account and tenancy, and that's the shaded in blue above on the right. Users do not pay for any of the Oracle managed container infrastructure. The gray area on the left, that's the control plane. The control plane enables you to configure those services, maintain operations, versions, availability, etc. Users will pay only regular fees for the compute, storage, and networking used in data plane. So that's the blue area on the right, where your applications will run and your data will be stored. So just to finalize here, did you know that some cloud providers charge you for the master nodes and services, the control plane on your left side that you see here on the slide? I'm talking about the free service that we provide to our users. So OKE and OCR not only provide a reliable and robust environment, but also a very cost-effective platform for you and your users. I have a couple more slides left, so let's use them well and talk about some of the unique capabilities we have available for you. Like, how about using OKE with other Oracle services? Well, Oracle provides service broker service to make it easy for you to get your microservices talking to other Oracle Cloud Native services. Oracle Service Broker is an implementation of the Open Service Broker API that you can use in a Kubernetes cluster to provision and bind to OCI services that your application depends on. It includes integration with key OCI services like ATP and ADW databases, streaming service, object storage, and we have a lot more coming out soon. The main key benefit of the service broker is reducing the complexity in the app deployment. So it's very easy to get your OK microservices talking to other Oracle Cloud services like the Oracle Database service that I just mentioned to you. Okay, what about persistence? How to make sure that the data is persistent with OK? As you might know, applications or microservices can be categorized as either stateless or stateful. And containers are very well suited for stateless apps, but require the use of external data for stateful apps. So stateless apps, they do not require persistence. They are easily redeployable and easily scalable. And plus, they can be easily containerized. What about stateful apps? Well, they require persistence. They're more useful for complex use cases. And a good example of that would be like an e-commerce website that keeps track of your cart as you shop. So it basically keeps track of your state. OKE provides servicing capabilities for both stateless and stateful apps. And along with that, you also have the capability to integrate your apps with Oracle Flagship's autonomous database and storage services like block and file storage, as you saw in the previous slide. Okay, this is my last slide. And here are some highlights of new features we have announced recently that I would like to share with you. For example, Kubernetes version 1.16 is now available and 1.17 is coming out soon. Cloud Shell is a web browser terminal that you can use to perform all of your operations directly through a browser. OK metric options are now available for users, and pod secured policies that control operations that the pods can perform on a cluster is now available. Excellent. Since you know more about Oracle Cloud Native Services, let's see how you can use Nirmata to manage OK. Now I'll turn it over to Ritesh, Nirmata founder.
All right, thanks, Gilson. Today we're going to talk about managing Kubernetes applications on Oracle Cloud using Nirmata. So just in terms of the agenda, we'll start with some introductions and then jump into why Kubernetes and what's driving the adoption of Kubernetes a little bit. Talk about some challenges and then dive into how Nirmata helps those challenges and integrates with Oracle Cloud to provide an end-to-end solution for Kubernetes management. We do have a demo at the end, so we'll watch some of these capabilities live. So in terms of introductions, I'm Ritesh Patel, co-founder VP products at Nirmata. I have about 20 plus years in enterprise software, and yeah, have been working in cloud native Kubernetes ecosystem for almost since the inception. Prior to Nirmata, I was at several companies, including Brocade, Trapeze, mainly focused on software, leading software teams and delivering products. Nirmata is a, a company I started along with a couple of co-founders in 2013. And we started Nirmata to mainly focus on simplifying operations for cloud native applications. So those were the early days of containers, and a lot has evolved since then, since we first started the company. And today, as you probably already know, containers have become a de facto way of packaging applications, and Kubernetes has become the orchestrator of choice for delivering those applications. So we in Nirmata are part of the CNCF and the Kubernetes community. We are one of the ecosystem members who delivers a solution around Kubernetes. We have existing customers who are using our product in production. These range from small customers using public and private cloud to large customers delivering hundreds and thousands of applications, both on-prem as well as through cloud. So when you think about Kubernetes and kind of what's behind the popularity of Kubernetes, so one of the things obviously is having built ground up for containers. Kubernetes is extremely robust and a production grade container orchestration solution. It has over the past 5 years, it has been hardened. It has been used in a lot of different environments. So obviously, it's fairly stable. Even though it's evolving pretty quickly, pretty fast, the community is building more and more features and capabilities. The core is fairly stable at this point. What Kubernetes does is it provides a declarative API-driven interface so that a lot of ongoing tasks can be automated, and also at this point, more and more for the scale at which applications are delivered, automation has become more pretty much necessary, right? So Kubernetes provides very solid interfaces to be able to define applications and deliver them at scale. It's obviously given it's built for containers. It has built-in support for some of the microservices constructs like service delivery or service discovery and load balancing, things like that. As well as at this point, pretty much all major cloud providers have adopted and support Kubernetes. So given that is built as an open source project, part of CNCF, everybody is contributing as well as supporting it, and it has a large ecosystem of vendors such as Nirmata, who provide various solutions around it to fill in some of the gaps. So all in all, Kubernetes has had a pretty solid traction, and in the last 3-4 years has seen increasing adoption in enterprises as these enterprises move towards becoming cloud native and delivering the kind of agility that their customers expect. So while Kubernetes tends to solve a lot of problems, there are some challenges that are introduced with the adoption of Kubernetes. These challenges tend to be around operational complexity and even in some cases around the learning curve required to learn and master Kubernetes, and also sometimes it's not clear who does what when it comes to delivering applications on Kubernetes. So there's blurred responsibilities. So from our perspective, we look at a couple of different roles when we talk about Kubernetes. There are developers who are responsible for their applications, and then there are operators who are responsible for for ensuring the cluster is up and running. All of the infrastructure is available, storage, networking, load balancing, and so on. And then any other cluster-wide services such as logging, security, etc., are already provisioned and available. So from a developer standpoint, some of the challenges that we hear from our customers is there's obviously some learning curve when it comes to learning various Kubernetes resources. As you define applications, you end up with a lot of YAML files, and having to manage those requires some level of understanding of these constructs. But at the same time, it can get complicated, and developers end up spending a lot of time when they have to troubleshoot and deliver these files. So that's one of the areas. There's also there's no built-in CI/CD tools within Kubernetes. There are integrations that are possible, but that's up to the developers to kind of integrate and build based on which tools they're using. So that kind of potentially distracts developers from their core goal to which is to deliver applications. Then there's challenges around portability. If you're using a platform that is built on Kubernetes and it's highly opinionated, like the traditional PaaS platforms, that limits portability of your applications, which could be a challenge. And then in Kubernetes, there are various workload-related concepts like deployment, stateful sets, and so on. But really, there's nothing defining applications, so that's a context that's missing. And a lot of developers, application developers, are kind of tuned to thinking about managing and operating applications. So that it's a little bit of a change for them. So that's again something that Kubernetes doesn't provide out of the box. Now, when it comes to operators, there's several things that operators need to kind of work on or support, and the challenges that they face when they start to support multiple clusters, especially if these clusters are on different infrastructure. So there's inconsistencies in the way these clusters are set up and then in the way these are managed. There's Kubernetes does not have any built-in security, observability, and other kind of capabilities. So those are needed, and those need to to integrate with existing enterprise tools. So that's something that the operators need to do. If they, in cases when operators choose a particular Kubernetes distribution, that could potentially cause lock-in if those distributions have any proprietary extensions. So that's another challenge. And then a lot of cases, the growth in the adoption of Kubernetes is organic. Different teams end up using different tools, and now you have a lot of different kind of independent deployments of your clusters. None of them are alike, and then that makes it very difficult to support and manage over time. So these are some of the key challenges we see, and these challenges, as we've seen these with our customers, we spend a lot of time trying to address these in a enterprise friendly manner. So that takes me to Nirmata and what we do. So at a high level, our focus is day two operations for Kubernetes. So if you think about a customer's journey and or team's journey as they go to cloud native and adopt technologies such as Kubernetes, starts with planning and design, and then when they're ready, they jump into deployment, configuration, setting up your clusters and defining what goes on those clusters, things like that. Now, that's something that Nirmata can do as well. But that's typically done, maybe once, maybe a few times a year. But then after that, there's a lot of things that need to happen when it comes to day two operations of Kubernetes. And we kind of think of it as from two different buckets or through two different areas. There's platform operations, which deals with ensuring your clusters stay up and running and they're secure and highly available and so on. And then there's the application operations, where now you're operating your applications in these clusters, and this is typically what developers or DevOps teams tend to focus on, whereas the platform operations are done by the platform team or the operations team. IT operations team is responsible for that. So that's kind of where Nirmata fits in terms of kind of a quick, uh, high-level overview of Nirmata. Nirmata is a unified management plane for Kubernetes clusters and workloads, and it's built for enterprise DevOps teams. So, like we talked about the platform operations, on the platform side, some of the key capabilities that Nirmata provides are cluster lifecycle management, which includes deploying clusters. This could be public or private cloud, or we can even onboard existing clusters. Then it's providing identity and access management for those clusters, so that users can access those clusters, and then ensuring workload compliance for those clusters. So as your workloads are deployed, we can ensure that they are compliant and they don't violate any enterprise standards. And then on the application operations side, we provide a fully Kubernetes compatible application catalog where you can model and create your applications. Then you can define what we call virtual clusters. This is kind of allowing your users or developers to on demand create environments on these clusters. So in Nirmata, we have a concept of environments, where now you are splitting up a large cluster into smaller environments which developers can use. And then finally, the application management, which allows developers to manage the full life cycle of the applications. So these are kind of at a high level what Nirmata focuses on, and the way kind of we help from a day two operation standpoint are through those key capabilities. So, for example, for developers, we have built in the catalog, we have built in YAML modeling, which helps them learn about Kubernetes, as well as not have to deal with some of the low level YAML syntax. Then we have Nirmata provides integrations with various CI/CD tools, so that the process, your full end-to-end DevOps pipeline can be set up. And the one of the challenges we see with CI/CD tools is, while they can deploy to clusters, you don't get any visibility into what happens after that, and that's kind of what Nirmata addresses. Nirmata also has a built-in application context, which can be used to deploy a set of resources or YAMLs together, and this lets developers focus on at the application level, instead of having to deal with individual YAML resources. I mentioned earlier about virtual clusters, which can be used for developers to create environments on existing clusters. This also allows operators to enable essentially multi-tenancy on a cluster, where now they can have a large cluster and share it across teams and across users. So Nirmata provides full self-service workflows that helps these developers create these environments, deploy applications, and manage them. So that's all available. On the operator side, Nirmata is completely infrastructure agnostic. So as long as the clusters are Kubernetes compatible or certified, Nirmata can manage those clusters. And through our integrations with cloud providers such as Oracle, we can also onboard clusters. In Nirmata, you have what we call cluster types, which can ensure that you clusters that are created in Nirmata are consistent, and so that every time a new cluster is created, the configuration is same, and that enables or simplifies overall management of these clusters. Next, through workload policies, operators can automate governance and enforce or ensure best practices and security compliance. And this is very important for customers in potentially in regulated industries where they want to make sure that applications don't violate any of their security and compliance policies. So overall, Nirmata is a turnkey, composable platform, very flexible, and delivers a solution across clouds, or it can be used in hybrid cloud environment. And more and more we are focusing on features that help with resource utilization visibility, infrastructure costs visibility, and optimization. So there's a lot of things that are provided out of the box. And in terms of high level architecture, this is what Nirmata looks like. So there's the Nirmata management plane on top, where we have a lot of these different features and capabilities. And then there are clusters at the bottom. Those could be cloud or on-prem, and these clusters, we deploy a Nirmata controller in these clusters, which securely talks back to the Nirmata management plane, and that's how, through that controller, Nirmata can interact with clusters, provision, deploy applications, enforce and ensure compliance, enable access control, as well as provide visibility and monitoring for your applications. So in terms of how Nirmata works with Oracle, there's two aspects to this. So there's so Nirmata is a management plane, like I mentioned earlier. It's pretty much infrastructure agnostic. We integrate with different flavors of Kubernetes. So with Oracle, we have integration with the container engine for Kubernetes that's on the Oracle Cloud, as well as the container registry and the object storage for backups for your cluster. And Nirmata can also deploy clusters directly on bare metal nodes. Here Nirmata can deploy clusters on Oracle Linux using the Oracle container runtime and Oracle Kubernetes. So for on-premises, we integrate with the open source Oracle Kubernetes components, and then for cloud, we integrate with the container engine for Kubernetes, as well as the registry and the object storage. So that's kind of quick overview of Nirmata and what we do and how we work with Oracle. Next, we're going to jump into a short demo. And in the demo, I'll try and cover some of these capabilities in Nirmata. We'll start with creating an Oracle cluster, and then look at how add-ons can be deployed in the cluster, how applications can be deployed, and quickly look at policies, as well as you look at the backup for your clusters. So let's jump in. All right, so what you're seeing right now is a Nirmata dashboard, and this dashboard shows you a quick view of the clusters that are already in Nirmata. They are showing green. That means they're up and running. I can click on them to view the details, and I also get a quick summary of what's currently in Nirmata. Now, I do have my Oracle Cloud account set up over here, and this is what I'll use to actually show you how we can deploy clusters in the Oracle Cloud through Nirmata. So before that, a few things from a setup perspective. Nirmata provides full kind of SAML and OAuth capabilities. So if you want to use SAML for your users, to centralize authentication, or you want to use OIDC, you can. In Nirmata, you can create users and then assign those users to teams, and then you can allow those teams or give those teams access to things like clusters, environments, as well as catalogs. Then in Nirmata, you can also onboard image registries. So here you see we have the Oracle image registry. So this is the OCIR, the registry that I have set up in the Oracle Cloud. And here, we can see the images that are available in that registry. The setup for the registry is fairly straightforward. You just need to provide the name, the location, which is the endpoint, as well as the username and password. And then from Nirmata, this registry is accessible. And what's more important is, as and when applications are deployed from this registry, Nirmata will automatically apply the Kubernetes secrets or the authentication information to download the images. Once the registry is set up, you can set up the cloud providers. So here I have my Oracle Cloud account set up. So the one I will be using is the Oracle Nirmata, which is I have an account set up in the Phoenix region, and all of these, the tenancy ID, the user ID, fingerprint, and the private key are needed so that Nirmata can talk to the Oracle Cloud through the APIs. So now, once that is set up, we should be able to deploy the cluster. So in Nirmata, like I mentioned, we have what we call cluster types, and these are the templates, if you will, that you can create beforehand. So if for Oracle Cloud, if I want to create a cluster type, I can create a test type here, and then select my credentials that I want to use, select the region. In this case, I have access to Phoenix, the version, and then the node pool configuration. And then if I want to install any add-ons like the Ingress or other add-ons, I can select those for this, right? So I have already created an OKE demo cluster type, and I'll be using that to create my cluster. And the idea is that this cluster type can be reused. If you want to create multiple clusters, you don't have to re-enter or type in the configuration again. You can actually just reuse it. So next, to create an OKE cluster, what I can do is on my cluster screen, click on the Add Cluster option, and it gives me several different options. So I can create a custom cluster through Nirmata. I can create a provider managed cluster through these providers, and or register an existing cluster. So in this case, I'm going to select OKE as the option, and I'm going to create an OKE demo cluster, and I will create the OKE demo cluster type, which I created earlier, and then select the node count and click on create cluster. Now at this point, the process for creating the cluster should get started. And to quite quickly show, I switch over to my Oracle account, and I can see that I have an OKE demo cluster in the creating state. So at this point, Nirmata has requested the OKE creation of the OKE demo cluster, and now the provisioning is underway. And this typically tends to take anywhere between 5 to 7 minutes, depending on the region and other factors. So while this is happening, what I'm going to do is walk you through some of the other capabilities in Nirmata. So we'll start with environments. Or rather, we start with a catalog. So when you want to deploy, before you want to deploy an application, you can create an application in the catalog. So and that's pretty straightforward. You can create, you can provide the application name. And if you have your YAML manifest for your application, you can drop those here. But if not, you can just click on create, and it's going to present you with all these different options where you can now actually configure your application. So let's go ahead and say I want to create a workload, and that's going to be a deployment. And in this case, we'll use the Docker Hub registry and look for a public Nginx image. And it pulls down the tags. I can pick one of these, I'll just pick the latest tag and provide the image pull policy, and then add the ports. And pretty much once you do that, and behind the scenes, the entire deployment is created. You can see all of the different settings, and you can also look at, if you want to just look at the YAML, you can actually see the YAML. So similarly, you can create different applications. And I also have here an Nginx application I created, and notice this one actually uses the Oracle, the image that's in my OCIR registry. So that's pretty much what it takes to create an application, or to add different resources to your application. Again, this is completely Kubernetes compatible. So we support services, ingress, network policies, config map, secrets, pretty much all of the main Kubernetes resources that typically build application. So just to give you an example, here is a little bit more complex application where I have 3 deployments and with different replicas, as well as a bunch of services, ingress. So yeah, it could, depending on your application, there may be a lot of different resources. And again, you can see all of the YAMLs when you actually export the YAML file. So now, once you have your application, the next thing is to actually deploy your application. So here we talked about the concept of virtual clusters or environments, where I can as a developer, I can request an environment. And before I do that, I'm going to quickly show you for an operator, if they want to specify any resource quotas for environments, we have something called environment types, where you can specify different resource quotas, and this can limit your CPU, memory, and so on for your environments. So for developers, when they create an environment, they can just specify the name, which type of environment, which cluster. So I'm going to use my other cluster, the prod demo, because the Oracle cluster is probably not provisioned. And then if they can actually customize the namespace if they want to. Once they do that, the environment actually on the cluster, it actually creates the namespace, and now you can start deploying your application. So you can say, I'm going to deploy my Nginx demo app from the catalog, and then in the catalog we'll pick up the application that we just created and then deploy it. So basically what this does is it actually sends down all of the different YAML resources to the cluster. You can see the resources actually in the cluster, and then we listen to the cluster events and update your application state, right? So here you can see the Nginx is already deployed and running in the cluster, and it's running on my prod demo cluster. Now you can see from my OKE demo, it's almost there. It's the provisioning of the control plane is done. I can click here and I can see the control plane is active, but at this point, the nodes in the node pools are being provisioned. So you can click on the node pool and you can see the nodes are not yet updated. So once the nodes come up, then you'll see that cluster available in Nirmata. But while that's happening, let's look at a few other things. So we talked about cluster policies. In cluster, in workload policies, you can actually define policies such as disallowing root users, disallowing latest tag. These are all policies that that you may define Another one is disallowing privileged containers or to privileged pods. And these are these policies are built for a Kubernetes engine that we have open source called Kyverno. And these are highly customizable. And once you have these policies set up and apply to your clusters, you can actually see which resources violate these policies. And then you can request the application owners to fix these violations, right? So here you can see, some of these resources, or in this case, deployments violate my disallow privilege policy, and I can take any necessary action. Now, for policies, you have the option of auditing, just providing audit, or you can enforce these policies. So in this case, because it's audit, I'm just showing a violation. But if these are enforced, you can actually it will not let the pod actually come up. So that's what workload policies are all about. Again, this is highly customizable. These policies, you can through these policies you can actually validate any configuration or resource configuration. You can also mutate the configuration. You can create new resources. All of those, it's flexible. It's very rich in terms of what it allows you to do to dynamically configure your cluster. All right, so let's go back and look at our cluster one more time, and looks like it's still updating. It's still not yet ready. So while that's happening, let me show you a few things on the application management. So I'll go to my prod demo cluster, and in my demo environment, I can see my application Nginx was deployed. From here itself, if I want to scale this application, I can do that. Or I can create a horizontal pod autoscaler within my application to scale dynamically. I can also update the image itself over here, and that will trigger a rolling upgrade of the image. A few other things I can do is for any of the pods, I can actually view the logs. So I can click on the pod, and I can click on the view logs button to spin up the log, or I can actually go and spin up the shell into the pod itself. So maybe let me just quickly refresh and see if it shows me the shell. So in this pod, I can actually shell into one of the containers, and this is where I can actually look at the logs of that pod. So all of that can be done. There's no need to give need to have additional SSH access to the nodes and things like that. Everything can be done remotely. And then at the application level, we have things like activity, all of the different tasks, events, and even alerts to indicate if something happened. So that's kind of a quick overview on the applications side. Now, next, once your application, we also, if you want an existing application, if you want to even clone an existing application to a different cluster, you can actually do that over here. So in this case, I'm going to clone an application and into a different cluster or different environment. It could be a different cluster, or it could be the same cluster but a different environment, and that will clone that application and deploy that in a different environment. So now you can see it's in my this different guestbook environment, and I have a clone application. So that makes it very easy. This is if you want to replicate your application across clusters or even within the same cluster. All right, so let's look at our cluster and look at the status of the OKE demo cluster. So here you can see the cluster is awaiting the controller connect. All of the cluster tasks have been completed. The creation has been completed, and now my cluster is connected. So this is kind of what it takes, and it took roughly around 11 minutes or so to create the cluster. And now in the cluster, you have several things you can see. So some of these screens will start filling up as we collect more information, but you can see the components, you can see the node pool, you can actually see the more details on the node itself. You can actually look at all the different resources, namespaces, pods, and so on. And then you can also deploy what we call add-ons. So what I'm going to do right now is deploy the Valero add-on, and this lets me configure backup. I have my Oracle object store configured already, and I have a bucket called cluster backup. So what I'm going to do is configure this in my cluster, and for that, first thing I need to do is provide an access key and the secret. So I'm just going to copy paste it. Since it's something complicated and I don't remember, I'm going to copy it over here. And this will go ahead and deploy the Valero add-on. Valero is an open source project which has built-in capabilities for cluster as well as application backup. Right. So now the Valero is being deployed. It's here. It has two components, a Valero and RESTIC, and it may take a few minutes for Valero to come up. So while that's happening, we look at some of the cluster. On the cluster side, we look at the analytics. We don't have much data yet. The data is being collected. We also have activity. It kind of tells you I just deployed an add-on, as well as I created the cluster. And then we have some settings for access control and other things. So that's all of this is available in the cluster. And now you can see some of these graphs are being filled up. So let's check on the Valero add-on. So it looks like these are coming up. So we'll go ahead and now configure the add-on on the cluster, and I'll show you how do you configure Valero to back up a cluster. So first things we need to do is configure a location for backup, and I'm going to call this default. In case of Oracle, I'm running in the Phoenix region, so I'm going to provide the Phoenix, set my region as Phoenix. There's the endpoint URL that I'll provide. And then I'm going to select the path as true, and then give the bucket name, which in my case is called cluster backup. And prefix, in this case, I'm going to just use my tenant compartment name in Oracle Cloud. So that I'm going to use as a prefix. So at this point, my backup storage location is created, and I'm going to create a volume snapshot location. And now I'm ready to start scheduling backups. So to schedule a backup, click on the Schedule tab and create a backup. I'm going to call it Demo Backup, and I'm going to pick a namespace that I want to back up. Let's say I want to back up the Nirmata namespace. And I'm going to select the default storage location. And there's no volume, so I'm just going to back up my applications running in that namespace. So here you can schedule a backup. You see my schedule has kicked in. It's enabled, and then within a few minutes you can start seeing the backups being created periodically for that backup. So if I go back to my object store, as these backups are created, I'm going to start seeing content over here. So already seeing, for my demo backup, I'm already seeing some of the backup data over here. And now once the backup is created, you can easily restore from that backup over here. So if I click the restore button, it will restore the contents of the backup into the cluster. So that's pretty much what it takes to back up your applications through Nirmata and then restore them in the cluster. Now, one final thing I'm going to do is, since we have the OK cluster, we have all of the resources. What I'm going to try and do is just deploy an application on that cluster. So we're going to say, call this an OK demo app, and we're going to, in this case, use the OK demo cluster. And in this, now I'll deploy my Nginx app, but this is the one that I have built using the OCIR, the container registry, Oracle Container Registry. So, so this is the application, and that's pretty much all I need to be able to deploy that. And now you can see those tasks show up. And then soon we'll see events coming up, and the application go into application reflect the running state. So that's kind of at a high level how Nirmata helps with Kubernetes day 2 operations and management, and through our integrations with Oracle Cloud, we are able to provide this end-to-end capability both for managing your clusters, which includes upgrading your clusters, which includes resizing your clusters, all of the other capabilities, and even if you want to provide kubectl access to the clusters, all of that is possible. And then deploying, managing, and providing visibility into the application. So you can see all the applications that are deployed across all of the clusters, or you can filter them by clusters, and all of that is provided through Nirmata. So just to summarize, so as with Nirmata on Oracle Cloud, we leverage the Oracle Cloud infrastructure, like the Oracle Container Engine, the Oracle Container Registry, the Object Store, and provide platform and application operations on top. The platform operations are targeted at ops teams for cluster workload policies, the cluster management, as well as shared services. And in the application operations around catalogs, Nirmata also has GitOps integration, change management, observability, and so on. Right. So that's what we provide as an end-to-end solution. This is a fully integrated solution. It's already Nirmata integrates at the API level, so there's nothing extra to be done, no scripting, nothing else. It's a single pane of glass. So today, in my example, I had multiple clusters, and all of these clusters were deployed in different locations. One was a lab, a couple of them were lab clusters. One cluster was in the Oracle Cloud. So this Nirmata becomes your single pane of glass for all the clusters. And then through the application lifecycle capability, you can operate again across clusters, across clouds, across environments, and more importantly, enable self-service DevOps. Because today, in today's day and age, the developers need the agility, need the velocity to build their applications. So that you can provide through Nirmata, while ensuring compliance and governance and making sure none of the best practices are violated. And then finally, from an operation standpoint, with integrated alerting, monitoring, correlating alarms, you get alerted or notified in case of any issues, and you can plan for any disaster by enabling the disaster recovery as well as portability capabilities of Nirmata. So this wraps up my part of the presentation.
Thanks, Gilson and Ritesh, for this very useful presentation and demo, and to all of you who attended our webcast today. This live webcast has been recorded and will be available in the next few days. If you have any questions after the session is over, feel free to contact the speakers directly. We appreciate your attending this webcast, and we hope you have a great day.